Right. Today we will start our new chapter, which is about input-output operations. So how to read, how to process files, how to read data to files, and how to read from the files. And have you seen it in Python class? How to? Okay, then things will be much easier. So just as a very basic concept that you already know. For now, what we were doing was always temporary because we were keeping the data in the RAM, which means that when we close the application, when we turn off the computer, all that data would be gone. So if we want to have a more permanent data that we will not lose once the computer is turned off, we want to write it to the hard disk. So this is uh, uh, so that we will be able to see the data when we turn on the computer again. So what are these hard disks? Well, any actually storage, secondary storage device. It can be a hard disk, optical disks, the flash drives, magnetic type, so that we want to write our data to there. So that the data will be persistent, we won't lose that. This is the main idea. And let me ask you, why do we do that? Like, why do we lose the data in RAMs?
Why do we lose data in routes?
Hmm?
Like, why do we lose data in routes?
Yes.
It's because there's another memory dedicated to like a long-term memory.
Yeah, why RAM is short term?
Because we're using it constantly for different things. We are using it for programming.
Okay, but when I turn off the computer and on again, why it doesn't keep its last state?
Because it's designed that way.
Yeah, what's the thing about it?
So
Or why
do
do we need RAM? Why don't we keep temporary data? Like, why don't we use always the hard disk so that it will be always permanent?
It's easier to change. Because if it's in
Easier.
the hard disk, it will be permanent. We have to take it out, change it, put it back in.
What do you mean by the easy? Like,
It's
To manipulate?
faster, yes. So it is faster. So from a computer perspective, I will write the same line, probably, or not from a coding perspective, not that hard, but yes, it will be faster. RAM is faster. So why is it faster?
It's because it's limited to.
If I buy a
less,
small hard disk, will it be faster?
No, because it is like near to the CPU. It does not go to the hard
Just a physical location. So if I keep my hard disk too close to the CPU. So by design, it uses electricity to keep the data. That's why it is fast. But if you don't have any electricity, the data is gone. In a very basic terms. Of course, there are so many other complicated parts, but this is. Then the question is, okay, how do we keep the data persistent in the secondary storage? Because no electricity, but the data is still there. How is this possible? Let's say in CDs or this. This also explains why it is slow. Why is it slow?
Use magnets.
Hmm?
Use magnets.
In magnetic disk, yes. How about CD-ROMs? CDs.
CD is physical.
Physical,
It's
how?
in the surface of the CD.
Yes.
It's burned on it.
So yeah, in a CD, for instance, yeah, it literally has these tiny holes. Each represents 0 or 1. So when the reader is going over that, if it is 0, there's a hole, okay, it's 0 or 1, I don't remember. If it is not, then it's the opposite. So yeah, there's some physical, we give physical damage to write the data, and then that's why we read it. And especially in the old computers, if it's not an SD hard disk, you see that something is spinning around. So you see some noise about it. This is also, again, to read the data, there's a arm that needs to move mechanically, a mechanical arm, and it needs to spin around, so that's also mechanical. That's also it is slow. It's not in the speed of electricity, there's really some movement. That's why we do not keep all our data in the hard disk. We don't want it because it will be very slow compared to when we keep it in the RAM. But of course, the RAM has this disadvantage, which is it is temporary. So we have to save our data, write our data if you want to make it permanent. Now the question is, okay, so we want to write them to files. What is a file? A file is basically a sequential, a sequence of bits or bytes, if you want to name it in that way. And in each operating system knows where a file ends or begins by some end of file markers, or maybe it also might keep the total count of bytes in that file. So when we are talking about the files, we have two separate files, types of file. One of them is text file, like our TXT files, our Java files. These files are designed for us to read, for humans to read. Like when I open my Java file, now I'm able to read this because this is for me to write it, for me to read it. But what is a binary file? Well, if I go to my, let's say here, if I open my class file, the file that I compiled, my Java file, so we get in that class file. If you open that, well, let's try to open it with a text editor. We'll not run it. We just want to see what is it's in content. So I want to open it with a text edit application. Okay, this is its content. So we see some weird letters also. The reason is that this document is binary. It's not designed for us to read. It's for the program to run. So we are not expected to read it. If we attempt to read it, we will not, because we see these weird letters because it's written literally with bits. And the program is just trying to convert it to some letters. Sometimes it has a meaning, and sometimes it's not. That's why we see this kind of a weird document. But then the question is, okay, why do we have these bytes? Well, okay, it's not for us to read, but then can't we also have a document that is for programs to write and read and for humans to read and write? Like, why do we create a document that is not readable for us?
Because it's readable by the machine, the compiler.
Yeah, but the machine can also read my Java file. Like, it can also read this. But why do I need a file that is binary, that I'm not able to read? Like, I created a file, but I'm not able to read. It's just for the computer. What is the motivation here?
For space, storage space, because ones and zeros, it's 1 byte.
Ones and zeros for space may be one reason, but
faster.
it's not guaranteed actually for this one.
Machine code is faster, I guess. It reading
Faster,
would be
yes. So when we have a text editor, eventually all of them are written as a sequence of bytes. Like my .java file is also a bytes, but .class file is also bytes. But the thing is, like let's say it in this way: you are playing a game, okay, and then you want to save the game so that you will be able to continue later on. You will just load it. So when you hit the save the game, what happens is it creates a file actually, in which it keeps the current status of your game. Like maybe if you have a character, its status is live, what kind of weapons it has, what is the map, how many characters are there, and so on and so. But from a computer perspective, what are those? Well, the live, well, it's an integer. The map, it's a maybe 2D array. So all of them is actually a different data type. If I attempt to write it as a document, as a text document, so humans can read, I can also do that. But I have to first convert them to text, a string, and then write it. But then the computer doesn't need it. The computer, because well, no one will open a load document of a game and then try to understand, okay, what is this status of the game? So you will not use it. So that's why we create binary files in which we don't have to convert it to a string. If the data is keeping like, is your player alive or not, that's a boolean. I write it as a boolean, just it. If it is an integer, that's 4 bytes. Okay, then I keep this. I write that variable as an integer, as a 4 bytes. If it's a double, I write it as a 8 bytes as a double object. If it's a short, it's a 2 bytes. So how I keep the memory, I basically, this is my memory in the RAM. I write it in the document as it is in my memory, so that I don't need to convert it to string when I'm writing. So writing will be faster, and I don't need to convert it back to original values from string in a binary format. So that's why loading will be also faster. So the thing is, yeah, why do we need, in short, why do we need binary files? It is faster. It is faster because we don't need to do this conversion. And it will be easier for us to write that. We will see. We can just say that, okay, write this object, and then the Java will handle it. I don't need to say, okay, how can I convert an object to a string? So this is not an easy question to answer, but we don't need to deal with this. And regarding the size, well, it might or might not be. Like, if it is an Boolean, if you want to convert to string, then it will be TRUE or FALSE, false. So there's 5 letters or 1 Boolean. So we will gain some space. But if the number is small, like integer is 1, so I can write it as a string, 1 letter, or 4 bytes for 1 integer. So the space is not guaranteed. It might have some impact, but I don't know. It depends. But the main idea is it's about the fastness, about efficiency of writing the file to the disk or not. And well, now let's continue with the Java. So when we start a Java file, Java creates 3 objects that allows us to do some operations actually with 3 stream objects, which are system.in, system.out, system.err. Actually, we know these objects. We use it like system.out println. So we use it to print messages to the screen. System.in, we use it with the scanner to get the data from the keyboard. And system.err, what is this? For the error messages. Again, it will print the messages to the screen, but in red or so. But just to separate that this is about errors. And if we want to do an operation to the files, so for these cases, we don't need to import anything for these one. But if you want to, for these ones, we don't need to import anything. But if you want to do some operation right to a file, we need to import this Java I/O operation library. And well, let me give you this. There are many different ways to write to a file and read from a file in Java. We will see just 2 libraries for that, or 3. But there are many different ways. And you don't need some cool algorithms to do I/O operations. You just need to know, you just need to be aware of the libraries and which one you need to use and which functions they have so that you can do this. That's the only, so it's not, you don't need to develop some sophisticated algorithms. You will just say, okay, I need to read the file. Okay, what kind of functions I have? Okay, I need to call this. Then I need to call this. This is the main part. So you might also find it a little bit boring that you will see that we will just go over some existing libraries so that you will be aware of what you have. And again, since there are too many and each of them has a different parameter, different ways of reading. In some of them you need to give just the file name as a string. In another one you need to create a file object, and then for that file object you have to give the file name as a string. So all of them are different, and it is really hard to memorize it. So as a relief, in the quiz or final exam, I will again give the class or the function definition, so that I don't think that it is meaningful to memorize these details. So I will give this kind of a cheat sheet. But it is important to be aware of what you are able to do, so that at least you will not lose time. Okay, there was a function that allows me to read line by line. What was it? I forgot the name. Then you can check the cheat sheet and find it. But if you are not even aware that, okay, is there a function that allows me to read line by line? then you will lose some more time. Okay, so this is the main idea. Don't try to memorize all the details, but at least be aware that what we are capable of. So for these stream classes, for instance, we have, again, one thing that you need to be aware that, okay, what type of data you are writing. If it is binary file, then, and if you want to read from that, then you can use file input stream. But if you will write to a binary file, then you need to use file output stream. But if it is a text character-based file, if it is a text file, then you can use file reader, file writer, and buffered reader, buffered writer, scanner, formatter. There are all other functions actually you can use. Again, we will see just a couple of them.
Is that the same thing with Python?
Same thing, what do you mean by same thing?
Same methods of Python?
Well, Python has also equivalent functions, but I cannot say that it is same. Like in Python, you can just say open, and then it will open the file with and you just give the file name. But in Java, it is different. So the syntax is different. The things that you can do are same. Like what you can do with Java, you can also do it with Python. But the way that we write it is quite different. But still, yeah, the mentality is same. Like we need to first open it. Then we will do all the operations that we have to do, and then we have to close it. So this is also same in Python and Java, but the way that we write it is different. Okay. And first, let's go with this system.in function. This system, I'll go with this system.in. So what is this part? Well, this is the main part that you get an input to your program, and you can change it. Like you can say that, okay, I want to get an input from the keyboard, or, well, not from the keyboard, but I want to get the inputs from a file, like the file.txt. Then we have to use this set-in function. I will do it now. So what I mean is, let me actually do this part. I will copy paste this code. Let me select it. And then let's create another class for I/O operations. By I/O, I mean input output. It's the abbreviation of input output. I/O operations. All right. Let's zoom in a little bit. I'll make a copy paste. Okay, now it first gives me error because the library is not imported. So I first need to import it. Import file, input stream. And then it needs to be written in try-catch block. So one thing that you really need to be careful about is these try-catch blocks. Because the file might not be there. Then the program will crash because you are trying to open a file. If it doesn't there, then it will fail. So that's why we have to, for simplicity, I will just say that I will throw it through the function definition. Again, this is one challenge. Again, I don't think that it needs to be memorized, but some I/O classes, functions, forces you to write this opening statement or forces you to use try-catch blocks, and some of them do not. So which one? It really depends. So if you want to be safe, you can always put them in all of them in a try-catch block so that there will be no problem. But it will be some unnecessary actions. During the exam, check the definitions of the libraries. It will in a function definition it says, okay, this function throws I/O operation, I/O exception. If it says it, then yeah, you should put it. If it doesn't say, then you don't need it. But again, this is the main change is that there are too many functions and they are not working consistently. This is the main issue that I'm trying to raise. Again, we need to also add one more part. All right. Then what is happening here is now we set that system.setIn, and then we put a new file input stream. So file input stream is to get the data to our program, and we are changing our system.in function, system.in variable. Where should we get it, read it from it? By default, it was getting from the keyboard, but I want to say, okay, don't get the input from the keyboard. Get the input from this file. So what I will do is I will first create here a file.txt object. So I will create a file first. New file, and its name will be file.txt. All right, this is our file.txt. Just I will put some dummy message. I will save it. Then I'll go back to my Java file. Now when we set it, now we will get the input from this document, and then the system.in, it has this function, which is the read. It returns the first character in the file. So when we run this code, let's run it. Okay, the output is, as you can see now, it says H. Why is it H? Well, because in our file I put this hello message, and then its first character is H. That's why what is happening here in this code is it reads the first character from the file txt, then we convert it, but it returns as an integer. Because characters are returned as, let me double check. Yes, it returns it as an integer, as you can see here. So we need to be able to print it as a character. That's why I now convert it to character, and then I print it. So this is one way, but the main thing is that, yeah, we can change we don't need to always read from the keyboard. We can also do it from the documents. One practical way of usage, where can we use it? Well, let's say that you develop an application, okay, in which you keep asking users to get some input, and then you want to test it, okay? Well, you can either do manually, like you will run the program and then keep typing it all the time, and then check if it is working correctly or not. But it will be time consuming. What you can do also is that don't get the input from the keyboard, get the input from this file, okay? Then you will first create documents in which what you will write as a test option. Like I will first write my name, then last name, and so on and so. Maybe whatever input that you want to give to the computer, to your program, and then run it in that way so that you will automatize this process. And you don't need to run it and manually type it again. You will just provide different inputs to your program. So this is one of the ways that you can use it. Any questions so far? Then let me move on. The other one is I can also change where I will print my messages. By default, it is the console. But I can also change it by this code. I will also copy paste it and put it here. And I need to import the other libraries for this file output stream. That's why I'm getting this error. And also for the print stream. So what we are doing here is, okay, we first created, okay, I want to create this output stream object, which means that I want to write this to file.txt file now, okay? So, and then I change my the stream object, saying that, okay, I will give this, okay, there's a very high syntax that, let me break it down. We first need to create this print stream object, which takes as an object file output stream object, then in which we define the function. So we are basically saying that when we run this, okay, whenever we type system out println, don't write it to the console, but write it to this file.txt file. This is what I was saying previously. There's really a huge library memorization that you have to do if you want. Like, how can you write it to a file? Okay, there's a print stream function, and what is parameter? It's called file output stream. It takes the file name. To be honest, to memorize this, I find it unnecessary. Because it might change. It's so easy to get this knowledge. But just to know that, okay, but at least you need to be able to read a code. Like, even though you might not know the details, you can make a predicted guess, educated guesses that, okay, this is doing, trying to set the output option to this file. Okay, then what will happen? Now let's run this code also. So let me run this code. Okay, this is executed. Then when we go to this file.txt object now, it says this is an output redirection. So what is this? Well, in my code, I had said system out println, and now it redirected my output not to the screen but to the file. Why is this useful? Where can I use it? Why should I direct my screen output to some file?
When you want to write to a file.
To?
When you want to write to a file.
That's one option, yeah, that is valid. Where do we use the system out println in professional programming?
Oh, debugging.
For the debugging purposes, mostly to check the status of our program. Like if you open a professional software, they don't show you, okay, those print messages. Like if you open a Microsoft Word, you will not see that something is printing to our to the screen. It won't happen. So we usually use it for ourselves, for the developers cases. So, and if you have a really long document by a professional document software, there will be thousands messages that will you will keep printing it. Then what will happen is that, well, where do we use it? Well, we use it for debugging. Maybe there's an error. I need to keep a log of my program. So I can use it also to keep the logs. Like this user logged in, did these actions and so on. So I need to keep this also. So what I can do is one way is I can print those messages but direct it to one specific file. Then what will happen is if there's any problem, I can go open that log document and then see what happened. So I will, and if I don't do it, well, first, if the screen is closed, that data will be gone. And also what happens is if you print so many tags, it will be really hard to find it from the screen. So that's why it's a good habit to direct your output to some file. And also the other option is the system set in, which is, well, I'll also do it, copy paste it. But in that one, I will change one thing there. I will not say that, okay, these are the same files. Let's make it error.txt, okay? And let's give it, of course, a different name. Then what will happen is, again, this is a good habit. Like I directed my output to file.txt and the error output to another file. Why is that? Well, when I now compile my, I need to refresh this part to see this error.txt. Yeah, now it appeared here. When I open this, now it gives this is an error redirection. And the other one is, this is an output direction. So what is happening is, for the normal outputs, I'm writing it to a file. For the error messages, I'm putting it in another file. Why is this useful? Well, because let's say that I have an output of 10,000 lines, and then there's an error message in between. It will be very hard to find it. But what I'm doing is now, if there's an error, just put it in this message, put this file, so that I can just easily see that if there's an error in my code or not by doing this. So that I'm just separating normal output and the error output. So again, for debugging purposes. Any questions so far?
When we reset the system system.out or system.in. It stays that way until we change it again, yes?
Yes, so yeah, I can keep changing that. Yeah, that's a good question. Like, what I can do is maybe maybe I have different types of errors. So in my application, maybe I said, okay, this is a different part. So I said that error 2.txt, and this is a different error redirection. Okay. Then when I run this code, what will happen is again, I need to refresh it to see my new file here. Yeah. So that error2.txt has this message, and error.txt has the other message. So yeah, I can keep changing it. I can keep redirecting my output based on my needs, of course. Yes, please.
Does the file get cleared every time we run the code?
Oh yeah, that's a very good question. Actually, I would talk about when we come to the writing to a normal file. Short answer, yes. And I will elaborate on this in the following slides. Let's give 1 minute break, by the way, to take the attendance. Then we will continue.